7-4 natural base E practice solutions. So with these, we're going to start by graphing. The first function that we have is f of x is equal to e to the power of x minus 4. So we're going to use our calculator for this. We're going to type in that e button to the power of x. It'll give you, you're going to plug in that -2. Then you can hit enter, and then from there hit -4, subtract 4. If you do this, you should be getting -3.8. So that's the point, or the ordered pair, -2, -3.8, which is roughly here. From there, we plug in the -1. So that if we do the -1, e to the power of -1 minus 4 is going to give us -3.6. So -1, -3.6 is about here. Then 0, e to the power of 0 is just 1. 1 minus 4 is -3. So 0, -3. 1, we have e to the power of 1 minus 4, so that's -1.3. So 1.3. Then for 2, e to the second power minus 4 is going to give us positive 3.4. So 3.4 is about here. We draw our line through these points, and then we're done. For 3, we have f of x is equal to -e to the power of x. So we're going to plug in the -2, -1, 0, 1, and 2 for x here. So -e to the power of -2 is -0.1. So -2, -0.1 is about here. Then we have -e to the power of -1. That's -0.4. And that's going to be about here. So the power of 0 is just -1. So the first power, -e to the power of 1 is -2.7. So 1, -2.7 is about here. Then to the second power, we're going to have -7.4. So that's going to be about here. So with this, we are going to draw our line very close to that x-axis, because that x-axis is our asymptote. It's where that line doesn't cross that certain y value in this case. I'm going to draw a line through those points. For number 4, we have f of x is equal to 4 minus e to the power of x. So 4 minus e to the power of -2 is 3.9. So -2, 3.9 is about here. For -1, we get 3.6. So it's -1, 3.6, so about here. To the power of 0, 4 minus 1 is 3. So that's 0, 3. 4 minus e to the power of 1 is going to be 1.3. That's about there. And then 4 minus e to the second power is -3.4. So 2, -3.4. So we are going to draw our line through these points. And then we're done. For example 5, we have f of x is equal to e to the power of 1 minus x. So for the first one, we plug in that -2. 1 minus -2 is -1. E to the -first power is 20.1. So that's going to go way off our graph. We're not going to use that point. For -1, 1 minus 1 is 0. 1 plus 1 is 2. So that's e to the second power, so that's 7.4. That first one, that 1 minus -2 is e to the third power, I'm sorry. So the -1, 7.4 is going to be about here. The 0, 1 minus 0 is 1, e to the first power is 2.7. So that's going to be 0, 2.7, so about here. For 1, we have e to the 1 minus 1, so e to the power of 0, that's 1. So 1, 1. And then for 2, e to the power of 1 minus 2 is e to the -1st, so that's 0.4. So that's going to be about here. So again, we're going to go get really close to that x-axis, but not go through it, and then go through the rest of our points. Oops. For our next example 6, we have ln times e to the power of x, and we're just simplifying these. Remember, when you are multiplying ln and e together, they cancel out, and the only thing you have left is that exponent of the x. For 7, we have ln times e to the power of x minus y. So once again, that ln and that e are multiplying together. So x minus y is the only thing that's left over, and that's your answer. For 7, we have ln times e times negative x over 3. So that ln times e gets canceled out. Negative x over 3 is our solution. For 9, we have e to the power of ln. Remember, anytime e to the power of ln or ln to the power of e, they cancel out, and we're left with that 2x. For 10, we have e to the power of 3 times ln times x. So that 3, remember, same rule as when we're working with those logs. This is the same thing as e to the power of ln x to the third power. You have that e to the power of ln, so they cancel each other out, and you're just left with the x to the third power. For 13, we're going back to graphing. We have f of x is equal to e to the power of x plus 1. So this is e to the power of negative 2 plus 1. That's going to give us 1.1. So negative 2, 1.1. Then for negative 1, we have e to the power of negative 1 plus 1, so that's 1.4. So negative 1, 1.4. For 0, e to the first power is 1 plus 1 is 2. So that's 0, 2. For the first power, e to the first power plus 1 is 3.7. So 1, 3.7 is going to be about here. And then for 2, e to the second power plus 1 is 8.4. So 2, 8.4. So here we're going to get really close to that 1 and then go up as we go to the right. For 14, we have f of x is equal to e to the power of x minus 1. So we plug that 2 in, we get negative 0.9. So it's negative 2, negative 0.9. Oops. Then we have the negative 1, e to the power of negative 1 minus 1 is negative 0.6. So that's negative 1, negative 0.6. Then for 0, e to the first power is 1 minus 1 is 0. So that's 0, 0. E to the first power minus 1 is going to give us 1.7. And then e to the second power minus 1 is going to give us 6.4. So we're going to get really close to that negative 1 y value, and then go up as we go to the right here. For 15, we have f of x is equal to 1 minus e to the power of x. We plug that negative 2 in, we get 0.9. So negative 2, 0.9 is about here. For the negative 1, we get 0.6. So that's about here. Then we're going to get 0, 0, 1, negative 1.7, and 2, negative 6.4. So this one's going to get really close to the 1, and then go down as it goes to the right. For 16, we have f of x is equal to 10 minus e to the power of x. So we plug in that negative 2, we're going to get 9.9. We plug in that negative 1, we get 9.6. We plug in that 0, we get 9. Plug in the 1, that's 7.3. Plug in the 2, that's 2.6. So we're going to have negative 2, 9.9. Then negative 1, 9.6. 0, 9, 1, 7.3, and then 2, 2.6. So this one's going to get really close to that 10, and then go down as it goes to the right. For 17, we have ln times e to the power of 0. The ln and that e cancel each other out, and we're just left with that 0. For 18, ln times e to the power of 2a. The ln and the e cancel, so it's just 2a. For 19, e to the power of ln times c plus 2. The e and the ln cancel each other out, so we're just left with the c plus 2. And then for 20, e to the power of 4 ln x. The 4 is the exponent on the x, so we can rewrite this as e to the power of ln x to the 4th power. Now that e and that ln cancel out, so it's just x to the 4th power.